Unit test code is not usually shipped to the customer, and it often gets less care and attention than the code that is. I noticed that the design of this code is often really quite bad in the organisations where I do technical coaching. People seem to spend way more time than they should trying to understand and fix broken tests. The thing is, there are some important design patterns for tests that aren't that difficult to do that can really make a difference to the readability and save you time when your tests break. This is a guided learning hour, and that means it's a training designed to be done together with the other people in your development team. You'll learn software development skills and get experience with new tools and techniques. These are skills that your team should be able to take advantage of in your daily work afterwards. And you'll get much better results if you all take part in these sessions and support one another. I can pretty much guarantee it's more fun than doing by yourself. If you enjoy what you see here, please hit subscribe and like. I also have a Patreon, so if you want access to the online activity board and exclusive subscriber content, please check that out. If you haven't done one of these before, do go and check out my video, Guided Learning Hour, How To. And if you just want to prepare this one, there is a facilitator briefing towards the end of this video. Hello everyone, I'm Emily Bache, and today's session is about test design. We're using this shared whiteboard that everyone should have access to. First question, what is a unit test? Now, I expect you know lots about unit tests, and I would like to know just 3 important facts about them. And I'd like you to raise your hand if you have a fact to share, and then your facilitator will write what you say on a sticky note on this board. Great, so I expect you've now got a board that looks a bit more like this with a few sticky notes with some facts that you've shared. And I don't know what you've written, but that's not so important. What is important is that you have started to remember what you know about this topic and that you've shared that with the group so that everyone is on the same page. We're talking about unit testing. And now I have some things I'd like to share about unit testing design. So this is a unit test here on the screen. It's and there's a few things I want to highlight about it, including the 3 parts. But first I want to highlight that a unit test has a name, and the name should be unique and tell you something about what this unit test is for, what is the scenario that we're testing. So this test is called average integers because it's checking an average function for a list of integers. And there might, if you've got lots of tests in this file for different kinds of lists of integers, then maybe you need to be more specific about what scenario this particular one is. But, there's only this one to look at. That name seems okay to me. Okay, then the actual body of the test. The first line here is the arrange step. And here you can set up the object you're going to test and collaborators and stuff, but in this test, it's just actually some test data that we're setting up, a list of integers. The next line of the test is the act step, and this is where we're going to call the method that we want to check, and we're going to pass in, the test data. So that's the part that we want to check is doing the right thing, and the last part of the test then is the assertion where we check what happened. We're going to check that the result that we got back, in this case, was the average of those integers. And this is quite a straightforward test that's just checking this one thing. And generally unit tests should be straightforward and check just one thing and have these 3 parts, arrange, act, assert. And the names there just help you to remember that that's what you expect to see and helps you to read the test when you can identify those parts. These names for the parts, arrange, act, assert, was invented by William Wake, but I actually like this description from Tim Ottinger and Jeff Langer. They wrote, arrange, act, assert is a simple concept, and it probably only adds marginal value, but it costs nothing to practice, and it provides a consistent way to communicate. And coding is all about communication with the other software developers who have to read your code later on. So just this simple thing that doesn't cost you very much at all can improve the readability of your test and is worth doing. Some people prefer to use the words given, when, then to describe the three parts of the test, as an alternative to arrange, act, assert. And I mean, that's absolutely fine. If that's what you're used to and that's what your team is saying, then do carry on with that. I do find, though, that that language is more often used in acceptance tests than unit tests. So my preference is for arrange, act, assert. Another thing I wanted to point out here, though, was the use of these little comments. And I think that's just kind of distracting. I think you're better off just having blank lines to delimit the three parts. Just like I did in this first example, I've just got a blank line each side of the act step. And that's enough to make it clear where the three parts of the test are. Okay, so now we're going to do a little exercise in this. I want to look at how it affects the readability when you use this pattern. So I've got 4 little code examples, and I would like you to just label them with the arrange, act, and assert. You've got these little green labels here, and you can draw little arrows if you want to point out which line of code is being the arrange step and all of that. So I'd like you to have a go at that. And the other thing, when you've labelled the parts of the test, you can give your code a star rating. So I've got 1 star here, and you can duplicate that to show how many out of 5 you think this. So, I could give this 5 stars out of 5, or maybe a few less. So see what you think. And as I said, there are 4 examples for you to look at. So I've got these arrangement of frames. These are my 4 frames that I can use to show you. And these are the 4 frames that one of the groups could use. And I've put them like this so that you could just select all of these 4 frames and duplicate them for as many groups as you've got. If you're going to work in pairs, or individually, you can make as many copies as you need. And these ones in the middle, those are my solutions that I'm going to reveal in a minute. So first have a go at it, and then put the video back on and see how it compares with what I've got. Okay, so let's just go through these. This first one was quite straightforward. It was very similar to the same one I showed you earlier in the session. It's got 3 lines of code, arrange, act, assert. And I give this 5 stars for readability because it is actually very straightforward to work out what's going on here. But it is a very simple, just 1 line of code for each part, so that's okay. This next one, on the other hand, wasn't quite so straightforward. There are a few more lines of code here. And when you look at it, there are actually 4 act steps here. It's really 4 tests in one. And that makes it a little bit harder to read. But there's still not a great deal of code here, so I've still given it 3 stars for readability. But I would actually prefer this to be split up into 4 different test cases. This one is also a few more lines of code, but actually, if you look at it, there's only 1 arrange, act, assert in this. And the assertion is a little bit more complicated, which is why it's a few more lines of code, but I think it's still quite straightforward to read. So I give this one 5 stars for readability. I don't know what you thought. And then there's this last example. And this one is really quite complex to read. There are 3 act steps here, but it's a little bit difficult to pick out which ones they are because there's so much going on in the arrange step and there's so much going on in the assert step. Now, and the method name doesn't give you any help at all, so message test. It doesn't tell you anything about the fact that it's this command.encode, which is actually the thing you're trying to check. That's the act step. So I've given this only 1 star for readability. And I think this is an interesting little exercise to convert this into much more straightforward 3 separate test cases and compare how the readability is. So that's the exercise we're going to do now. First, let me show you a demo. In this demo, I'm using Rider and Resharper to refactor C#. But try not to get hung up on the details of the tool or the programming language. What is important here is the principles of refactoring. You're starting with a passing test. You don't change the production code. You just break that 1 test into several and keep each new test passing all of the time. Take small steps, use your refactoring tools. In this version of the project, I've actually got two versions of this test case, one with NUnit and one with XUnit. So you can choose the one you're most familiar with. And if you're working in a different language, hopefully there'll be the test framework you like there too. So this is the test that we wanted to refactor. Now, it's good to start from passing tests because when you're refactoring, you're hoping the tests will continue passing. So let's just check that first. But I did want to show you what happens if the tests fail. So here I'm just going to deliberately introduce a bug, and then I'm going to run the tests again. And you can see what happens now with the failure. So I get this message, oh, we've got a difference between the expected and actual strings. So that's good. The test has failed. It's found the bug that I just introduced. But when you look at where in the test it's failing, so we can start to understand what's going on, you can see it's this assertion right in the middle of the test that has failed. And that means to understand this, I need to read through all the code that came before, which is actually quite a few lines of code. And at this point, I have no idea whether the code that comes after this will work or not, because the test execution, of course, stopped in the middle at this assertion. So having the test arranged like this with multiple ACT steps not only affects the readability of the test, but it also affects how easy it is to interpret the failures, and it makes it harder. So I'm going to try that again at the end when I've refactored and see if it's any better. Okay, but first I better take that bug away that I just added. Good, so we're back at green. And now I'm going to try and split this apart into 3 tests. So the first thing to do is just select the whole test and duplicate it. So yes, I have introduced duplication, but in a good cause. So I would like to take the whole test because then I know that I'm starting with a test that works. It passes, and as I refactor, it should continue to pass. But of course, it needs a unique name. So I might as well name it well here, since I'm writing new test cases. So I'm going to name this session modification command encode, because it's the encode method that the ACT step is calling on the session modification command. And the first scenario that I'm going to work on is this last one, when the timer is deactivated. I find it kind of helpful to start with the last of the ACT steps when I'm doing this. My preference. So there's the ACT step. I'm going to separate it with 2 blank lines. And now I need to work out how much of this code I have beforehand that I actually need for this particular scenario. So this part in the middle here, that's just another scenario. So I'm just going to remove that. And there is the equivalent setup for the first section. And I don't think I need that. Maybe I'll just have a little look at that method. Yeah, it's just setting up some values. It doesn't look like I need to call that twice with different values. So I'm going to remove that line as well because it's doing the same thing. Now, what else do I need to do? Oh, yes, so this is referring to a variable that was defined up there. So let's define it down here too. This console.write, that looks like leftover debugging from when somebody created the test. You don't normally need console writes in a test case. You should be able to see what's going on from the assertion failure. So I'm just going to remove those. Okay, and the other assertion. Good. So now this hex string encoder is actually just going to move that down closer to where it's used. Okay, so this, and there's the other ACT step from the first section. Don't need that. Right, this is looking like it could work. Yes, okay, so there I think is a complete test case for the third part of the original test. And it's working. It's much easier to read. Hi, I'm Emily Bache. I'm a software developer and creator of Sandman Coaching. In my channel, you can find content for technical coaches and developers. If you enjoy what you see here, please hit subscribe and like. I also have a Patreon. So if you want access to the online activity board and exclusive subscriber content, please check that out. Okay, so let's try and do the same thing again for the middle part. And I can now remove that last part because I've got a new test for it. Just like I didn't break anything. Good, so I'm going to do the same thing again. I'm going to duplicate this entire test case so that I get a new test that I know should work. And I give it a unique name. And this scenario is when the timer is outside the range, according to the comment. So let's name it after that. Great, so same thing, identify the act step and put the blank lines around it, and then work out how much of the rest of this code we need as setup. So we don't need to set that up twice, we don't need to do the act step twice. That again needs declaring down there where it's used. Get rid of the console, get rid of the other assertion, and move the hex encoded down to where it's used. Cool. So that looks good. Great. I now got another test that only does one act step, and I can now remove that from the original test. So hopefully now all I need to do is just clean up the original test a little bit more here. So let's give it a better name. So again, this is session modification command in code, and the scenario here, well, I'm going to make a guess that it's something to do with it being 23 hours. If I knew this code better, maybe I'd be able to come up with a better name. So put the blank lines around the act step and see what else. Oh yeah, remove that console write. Otherwise, that's looking pretty good now. Great, so I think I've completed my refactoring now. So I'm going to try putting that bug back in and see how it looks now when the tests fail. Okay, so now only one of the 3 tests is failing, so I've immediately got a better idea of which scenario it is that I've broken, and it's something to do with the timer outside the range. I can see that from the test name. And then if I look more closely at this failure and go to the line of code where the assertion fails, now I've only got this many lines of code to read through and understand before I can understand more about this failure. And that's less code than I would have to read before. And I know that the other 2 scenarios are still working. So hopefully with these refactored tests, I'm in a better position now to maintain these tests. Now it's your turn. I'd like you to split into groups and work on also doing this refactoring. I'd like you to split this one big complicated test into 3 much more easy to deal with tests. Do it in small steps using your tools, checking that the tests pass when you've done the refactoring. And if you complete all of that really quickly, I think I've left some work for you to do here. The code isn't as good as it could be. There is some duplication now between the test cases. So have a go at refactoring that too if you have time. Great, so I hope you've had fun refactoring this test code and you've come up with something that's more readable now. Can you just spend the last couple of minutes reflecting on what happened today, and each person write a note about what you've learned? How does using the arrange, act, assert pattern improve test maintainability? Everybody write a little note. So this is my challenge to you today. I want you to find an opportunity to write a unit test. Design it well. Take some care and attention. Your colleagues or your future self might just thank you when it fails and they can more easily understand what went wrong. If you like this content, please tell your friends. Happy coding! This part of the video is for you, the person who's going to facilitate this session on my behalf. And I'm really grateful that you're willing to do this, and I'd just like to give you a few pointers to make it easier. Before I start sharing what I think, you should sit down and make your own list. Having watched this session and what I'm going to say, what do you need to prepare before you show this to your team? So pause the video and go make your own list first. Okay, so I hope you've got your own list, but I would also like to just remind you that these are some of the things that you probably want to have on that list. You're going to want to set up the coding exercise so that all the team members will be able to get hold of their code quickly. You might also want to look up your organization's test design guidelines and to see whether they mention the arrange, act, assert pattern that I talk about, whether there are any recommendations that your organization would like people to follow. The initial exercise where you're reviewing all those code samples and labeling the parts, you'll need a shared whiteboard with 4 code samples on that you'll want to prepare in advance. If you subscribe to my Patreon, you can get hold of a copy of the board that I've used. So consider that. But otherwise, you can find your own samples. And of course, don't forget to book the session in your team calendar. Now, during this session, again, there are 4 activities that you'll need to facilitate. The first one is a connect, and then that's just really fast, 2 to 5 minutes. Then the first kind of concept/concrete activity with the labeling in the code samples. Then the hands-on concrete practice, refactoring a test case. And then a really short conclusions activity as well. If you're not familiar with the 4C structure from training from the back of the room, it might be a good idea to look that up as well. So first, the connect. This is a 3 facts connect, and you can read more a description about what that means on the Sandman Coaching website. But basically, I've done the intro for you in the video. What you need to do is write down what they say on sticky notes. And don't put too much thought into that, just literally write down what they say so that everyone can see. Your job really is just to collect a few facts, 3, maybe 5, and then say, great, we've got enough facts, and move on. The point of this part is just to connect people to what they already know and to remind them, oh, we're talking about unit testing. Oh yeah, I know about that. And whatever they say is the right thing. Then the next part that you'll need to facilitate is this activity with the labeling the code samples. So you'll want 4 code samples. You can use the same ones as me if you've got my whiteboard, but otherwise you want a straightforward one, similar to my example from the first part. And the second example is the same one, only with more act steps. So it's got this structure: arrange, act, assert, act, assert, act, assert. So any kind of test that you can find that's just, not too long, but has all those extra act steps. The third code sample is well designed, but has a complex act or assert. So it's slightly more difficult to pick out which is the act step. No, sorry, slightly more complex arrange or assert step. That's what I mean there. And the example on my board has got a slightly more complex assert step. And then this is the code example from the exercise that we're going to do together in a moment. So you should be able to find that on GitHub. There's a link to it in the show notes. So during this activity, you could go around and help people if they're getting stuck and give them a few pointers. But probably the most important thing that you need to do is make sure everyone's got a copy of the code samples and that you stick to the time limit. Then there's the coding exercise. And here the difficulties you might run into is that it's difficult to get the initial code working. And so that's where some preparation is key. If you've already built the code and you know how to run the tests, you can help people with that. The other thing that might happen is that a few people are really good at this and finish really quickly, and they're like, what should we do now? And you can encourage them basically to improve the design of the tests even more and use perhaps a test fixture. But generally, if some people are finishing quickly, that's a good sign. So don't be too worried about that. Go around and help the people who are not finishing quickly in preference. And then there's the conclusions. Again, this is a really short conclusions activity. I just want people to have a chance to think about what they learned and put in their own words on a sticky note so that they can have a takeaway and remember it in their coming work. Because that's what this is all about. It's changing the way your team works in your code. And after that, it's just to put the video back on for the final closing credits and thank everyone for coming.